So thanks everybody for joining. My name is Nick Murison. Some of you I don't think I've met yet, so hi. Just as a bit of background, before I joined Miles, I was a security consultant. I started out in the security space about 16 years ago. And so I started out working at, for example, HP Trusted Systems Lab in the UK, where I did a bunch of R&D work. And then I got hired as a security consultant in the US. And the first couple of years, 3-4 years in the US, basically all I did was penetration testing for US customers. So I wanted to kind of share with you a bit of my experience from that, and also why I think it's a problematic thing that we do in security. So what is penetration testing? Let's start off with that, just to get everybody on the same sort of baseline here. I was going to do a hands up who here has done a penetration test before, but I don't know how well that's going to work. I've done one. Oh yeah, I know, you've done one. Excellent, okay. And I'm assuming that quite a few of you have been on the receiving end of a penetration test report, a lot of customers and so on. Basically, there's lots of ways of defining what a pen test is. So what I wanted to just sort of do was give a baseline definition. So essentially what a pen test is, we're asking the question is, what might someone do to our app or our system or network that could be bad? And is there a way of simulating that for ourselves without the attacker, without bad people doing it for us first? A lot of times you can call this ethical hacking, and it doesn't necessarily have to be against an application. It could be a web app, it could be a mobile app, it could be a back-end system, it could be an entire network infrastructure, it could be a building, or it could be actual people. Now this is something that's sometimes called social engineering or red teaming, and that gets really interesting and weird and freaky sometimes. But the end goal is, let's see if there's a way of breaking into the systems or people or buildings and so on, and see what we can learn from that. So first of all, pen testing is not all bad. So I thought I'd start off with some good stuff. First of all, hacking is a lot of fun, and pen testing is basically hacking but with permission. So yay. It's kind of a challenge. You're pitted against whoever built the system or the app or the infrastructure that you're trying to break. And for me, having some development experience, coding experience, was really useful because I could get into developers' heads while I was trying to break their applications. Sometimes it felt like a bit of a spy novel. Like this one time, I was trying to crack some crypto. I was testing this web app. There was a lot of data being stored in cookies. Like I'd log in and I'd get this massive cookie file, cookie set in my browser. It looked like a bunch of gibberish, but there seemed to be some recurring patterns in it. It didn't look like completely random data. So I did a bit of crypto analysis and discovered it's this really cool algorithm called Cipher, which is about 2,000 years old and really easy to hack or crack. It's not really even an encryption cipher. It's like base 64. So the customer was really impressed when I discovered how to do this, because I did it on a piece of pen and paper, and it was a lot of fun. Now the developers did throw in some extra bells and whistles, so it wasn't straightforward, but still. Another one I did was at a bank. I figured out how to transfer $1 million out of other customers' accounts into my account by paying them negative amounts of money. So I would pay someone negative $1 million and I'd end up with $1 million in my account. It was fantastic. I was really happy about this. I thought it was fantastically clever. The bank, they didn't seem very happy about it for some reason. So it can be a lot of fun, definitely. Also, it's very useful. I don't know how well this plays over Zoom, but I'd like you to meet my cat, Alex. Alex is a bit of a dick. He's not really, he's very affectionate. He's very, very affectionate. So he's so affectionate, in fact, that if I'm not petting him or my wife isn't petting him, he has to figure out how to get pets some other way. And so we have a Roomba as well. And a couple of years ago, our Roomba died completely, like the battery was dead. So I got a replacement battery, but I kept coming home to a dead battery, or dead Roomba rather. One day I was working from home, and lo and behold, I figured out what happens is the Roomba starts up, Alex chases it, corners it, and gets lots of pets. So this is something that, if the designers and the implementers at Roomba might have done some sort of adversarial testing, they might have discovered that, it seems like a weird scenario, but cats cornering Roombas is a thing. So maybe they'd learn from that and maybe build some algorithm to escape cats, basically. Well, some of the challenges around pen testing is that a lot of companies buy pen testing thinking that they're getting some sort of stamp of security. Unfortunately, this isn't the case. So a lot of times you might get a pen test report that says something like, given the 5 days of testing that we did, the limited user credentials that you gave us, no documentation that you gave us, also we didn't get any source code, we'll get either like we found lots of high-risk vulnerabilities, or we'll get we found nothing. Now, obviously, finding 10 high-risk vulnerabilities bad, that's a problem. But if the pen testers didn't find anything, we don't really know what that means. We just know that the pen testers they didn't find anything. So there might be a whole bunch of problems still in the app or the system. It's just we didn't have time to find them, or maybe we didn't have access to the right things to find them. It's a limited test. So you're not getting necessarily what you think you're paying for. Also, when it comes to application development and software development, pen testing causes a lot of friction. So imagine you've just spent 6 months slaving over your app. You've taken it from like barely minimum viable product to something that's customer ready. It's a good thing because business is getting really impatient. They want to launch this thing like last Friday. So how are we going to get this thing up and running? So you've like slaved over this thing. And then someone comes in, a guy like me, breaks the whole thing and hands over a report saying, your baby is ugly. You've just spent 6 months making this thing and it's ugly. It's broken. This doesn't lead to a very friendly relationship. I don't get a lot of support or collaboration from these people. I'm not really surprised. It's bad enough when I ruin someone's day after the fact, after I've done the test, but it's especially bad if I get introduced to the development team, and this is a direct quote from a customer, this is Nick, he's here to break your stuff. So that's how I got introduced to the development team. I got zero help from those guys the entire week I was there. So yeah, fun. Also, pen testing has risks. So ideally, you'd be pen testing an application in like a development environment or a test environment, something that looks like production but isn't production. Because if it is production, things can break in production, and that's never good. Like this is a screenshot from yesterday. This is T2.com. T2 is a tea company in Australia. They have shops all over the place, including London. One of my favorite tea shops. Their website was undergoing a penetration test by a company called NCC. And you might be able to spot that on this error page, there is a bit of text saying script alert NCC test. NCC is a large multinational security consultancy. They do a lot of penetration testing. They're very well known for it. This is clearly one of those cases where they were doing a pen test in production, something went wrong, and actually this happens quite a bit. And it's still broken 24 hours later, which is not good. Okay, so pen testing, not necessarily good, not necessarily bad, but what else can we do? Turns out quite a lot. Just as some examples I'll throw out here, I've sort of grouped this around sort of the 5 kind of main artifacts that we get in development. We have code, we have tests, we have feedback from operations, we've got requirements and architecture to start with. So first of all, code review. Look at the code. Ideally do it automatically because manual is boring. Threat modeling and architecture. So look at the architecture, look at what can we do to find issues as part of the design before we start implementing stuff incorrectly. There's also penetration testing, very useful, but not necessarily the first thing you should be doing. Now, so far, we're coming up with a whole bunch of flaws. We're coming up with bugs, we're coming up with potential security vulnerabilities and so on. So how do we get these things either fixed or addressed before they become a problem? Well, let's actually write some security requirements. There might even be what we call abuse cases. An abuse case is basically take a use case and flip it, make it negative, is the easy explanation. And then you can do things like risk analysis. We don't need to necessarily fix everything, but we should fix the really bad stuff to start off with. We can do peer reviews as part of, if you're doing pull requests, throw in some security checks when you're doing a pull request. And ops as part of operations and production, look at monitoring and look at logs and so on. Some people like to use bug bounties, could be useful. But if you're going to do bug bounties, make sure you've got at least some other stuff in place first, because you're going to need to have practiced how to respond when you find a problem. So if you, a lot of companies launch bug bounty programs and get inundated with security vulnerabilities. You want to have a process in place before you start inviting other people to look at your code. And then finally, I just want to talk a bit about kind of, if you abstract that up a little bit, talking about how security people we haven't been good at development stuff. So we tend to like to put in sort of, a lot of security teams are secret squirrel clubs. We hide away in a corner, away from the developers. And then every once in a while, we come through the door and we yell at you guys and then we leave. But we don't want to tell you what we're doing because we're an intelligence agency, but we're not really. We like to pretend that we are. So actually more sharing of knowledge and so on is what we want to do. And we want to build a culture where it's open. Look at processes. I mean, security processes tend to be these waterfall things that shouldn't happen anymore in modern development. So we should actually be looking at how do development do things and how can we fit security onto that, as opposed to how does security want development to work, because that's clearly not worked for the past 20 years. And then finally, technology. There's a lot of things we can automate. So there's lots of things that as security we're looking for when we gate stuff, where we're looking to make sure that you can't introduce new vulnerabilities. We can actually automate a lot of that in continuous integration and so on. So look for automation opportunities. There's not always an opportunity to automate everything. There's certain things that have to be manual. But if we can automate as much as possible, then we can actually spend some time on the really important stuff manually. And that was it for me. Thank you very much for listening.